MeshConnect Test Tool, RF Hardware Evaluation Software. There are three modes of operations when connecting your Universal Eval board to the MeshConnect Test Tool software. Mode 1 consists of one PC with MeshConnect Test Tool software and two universal boards connected. Mode 2 requires two PCs with MeshConnect Test Tool software and two universal boards connected. Mode 3 has one PC with MeshConnect Test Tool software, one universal board connected, and one universal board not connected. Let's demonstrate the MeshConnect Test Tool software with Mode 1. One PC with MeshConnect Test Tool software, but instead of using the two universal boards connected, we will use two Ember breakout boards that are connected. Here I have connected two Ember breakout boards via USB port. The one on the left will serve as a coordinator and the one on the right will serve as the end node. Let's power on the coordinator by connecting it to the USB port on the PC. An LED light will illuminate on the Ember breakout board, indicating that power has been established. Now that we powered on the coordinator, let's launch the MeshConnect Test Tool software. Next, click Auto Detect to detect the hardware. On the Select Mode screen, click Zigbee Mode, then click Submit. Since the board on the left will act as a coordinator, go ahead and use the default settings, then click Submit. The Test Tool software is now configuring the coordinator as a Zigbee device. After configuration, the MeshConnect Test Tool software interface will appear. On the upper left hand corner of the interface, you will see the module we're working with, along with the COM port, baud rate, and module type. On the bottom left hand corner of the interface, you will see the MeshConnect radio settings, where you can find the PAN ID, the source ID, RF channel, RF power, and MAC ID. On the bottom right of the interface, you can find the data log and the hyper terminal. On the upper right hand corner, there are several tabs. There is a PERT setup tab which runs a packet error rate test. There is also a range tab which I will cover later in this demonstration. There is a low power tab. There is a version tab. Let's click on Get Version for hardware specifics. Here you will see the stack version, the firmware version, the module version, along with the type of board, which is the Ember board. On the ADC tab, you can monitor the temperature of the module by clicking on Get Temperature. There's an external flash tab. Since there's no external flash on this Ember Eval board, this section is grayed out. There are some boards that have external flash present. The last tab is a network tab. This will display the coordinator we have powered on earlier. It is sending out a signal and looking for an end node to join its network. Now that we're familiar with the MeshConnect Test Tool software, let's go ahead and run a range test by clicking on the Range tab. Next, let's power on the end node by connecting it to the PC. You will see the LED light on the end node illuminate, indicating that power has been established. Now that the end node is powered and connected, let's launch the second instance of the MeshConnect Test Tool software and click Auto Detect. On Select Mode, click on Zigbee Mode, then click Submit. Since we already have the coordinator established, let's select this as an end node and keep the default settings, then select Submit. Now we're configuring this end node as a Zigbee device. Once configured, you will see a second MeshConnect Test Tool interface appear. On the end node interface, let's copy the source ID to the clipboard by hitting Ctrl+C. Then let's go up to the Range tab, select it. Then let's head over to the interface for the coordinator. Let's paste the source ID under destination address. Set the rate to continuous. Then click on Start Range Transmit button. As you can see on the coordinator module board, a green LED light is flashing, indicating that a packet is being transmitted. On the end node module board, a red LED light is flashing, indicating that packets being received. You can stop the range test by clicking on the Stop Range Test button. By stopping the range test, you can see that the LED lights stop blinking. Let's run a range test from the coordinator to the end node board by copying the source ID to the clipboard on the coordinator interface and paste it under destination address in the end node interface. Go down to rate and select continuous. Then select Start Range Test. This time around, you can see a green LED light flashing on the end node module board, indicating that a packet is being transmitted. On the coordinator module board, you can see a red flashing LED light, indicating that a packet is being received. You can also run a bidirectional range test. Let's go over to the coordinator interface and select Start Range Test. Now you can see that the coordinator and the end nodes are flashing LED lights. The green LED flashing lights indicate that packets are being transmitted. The red LED lights indicate that packets are being received. This is a bidirectional range test. You can now stop the range test by clicking Stop Range Test on both interfaces of the MeshConnect test tool software. This concludes our demonstration on performing a range test using the CEL's MeshConnect development tools. For more information, visit us at www.cel.com/meshconnect. Thank you for watching.